What's up, you guys? Silver here. I'm going to show you 5 levels of integration by parts. Let's begin. Let's start with level 1. So of course we have this very basic example here. Whenever you see or have a polynomial or monomial, pretty much any algebraic term like x squared or x to the power of something, any power rule, you always want to derive this. So we're not going to use this. Okay. In fact, I hate this formula. I would never teach it like that. If I in a actual calculus class, like I would always teach it like this, just because it's just a lot simpler. But this is how I would teach integration by parts. I don't ever use the ultraviolet light thingy-majig. Like this is how I kind of use the notation, right? Let what function is f prime, what function is g. That's how I kind of teach it. I don't teach it the UV one because it's just the notation is just really, it bugs me. It bugs me a lot. But in speed integration, we don't have time for that, right? We need to speed integrate. So we use the DI method. Okay? So let me actually write that. D for derivative, and then I to integrate. Again, this is not a tutorial video. I'm just kind of briefly explaining. So we always want to derive with power rule, and the reason is because this gets us to 0, and we like this. We like this a lot. Integrate e to the x, it's just e to the x. Okay. When we use this, the sign alternates. So now this is negative 2x. And then our answers is literally just this and the product of this as well. And so our answer is x squared e to the x minus 2x e to the x plus c. And that is our answer. Just like that. So throughout the, speed integration, we always use the DI method for integration by parts. Okay? Because it's just instant and very, very fast. So what about this integral? So now we have an issue. We cannot just do the power rule, right? X squared ln of x. Oh, well, we don't even know the integral of this yet at this level. So our first priority is actually logarithms. So we derive logarithms first and integrate with power or this power rule, because integrating with this is so much easier than integrating with this. And so now when we derive ln of x, we get 1 over x. Don't forget to alternate your sign, right? We want to alternate your sign. And then the integral of this is x cubed over 3. Do we keep going? No, we don't. We stop to where when we multiply these two, it's an easier integral, right? It would be lovely to have a 0, yes, but if we keep deriving, I don't think we'll ever reach to 0, right? So instead, we'll stop here, because this would give us, this is okay, because it's going to give us an easier integral, right? We only like to stop at 0 because 0 times some function is equal to 0. Oh, you integrate 0. Integral of 0 is 0. That's the reason why we like it so much. In this case, it'll never happen. But this is okay to integrate. This times this, easy integral still. So we're okay with that. Awesome. So we have this and we have this. So our integral, this is equal to this times this, x cubed over 3 ln of x. And then here, this portion here is the product, the integral of the product of these two. So it's minus the integral, this times this will give us x squared over 3 dx. Okay? Super easy integral. Our answer is just x cubed over 3 ln of x minus x cubed over 9 plus c. And we're good. All right, so now how do we handle inverse functions? To handle inverse functions, we use integration by parts. But how? What we do is if we have some inverse function, we derive it. We just straight up derive it. And the integral would be 1. So we integrate 1. Now, this is 1 plus x squared. Don't forget to alternate, right? And then integrating 1 is just x. Right? We're not going to reach to 0 because, well, we don't want to derive this again. But that's okay because we can integrate this very easily, right? It's just basic u substitution. Awesome. So this is equal to x inverse tangent of x minus the integral of this times this, x 1 plus x squared dx. Oh, this is super easy, right? So our answer is x inverse tangent of x minus the half of ln of 1 plus x squared plus c. And we're done. And that's it. Alrighty, on to level 2. We're going to do recursive integration by parts. And this is where it gets extremely a bit uncomfortable for a lot of students and beginners. So we're going to call this I. And you'll see why. You will see why. So I'm going to go ahead and derive sine 3x just because it's just easier to derive with trig functions. And then e to the 2x. Then cosine 3x here. Then negative 9 sine 3x. Now, of course, in integration, with this method, we got to alternate signs. Plus, but this will stay negative. And then here, this is half of e to the 2x, 1/4 e to the 2x. Okay? So then, of course, we still do this thing. Now, this is I, right? This is I. This here, e to the 2x over 2. Sine 3x. Okay. And then here we get minus 3/4 of e to the 2x of cosine of 3x. Let me move this. Just a bit there. There we go. And now, what is this? This is minus 9/4 integral of e to the, e to the 2x sine of 3x. Oh, well, isn't this integral the same thing as this? Yes and no. It's the same integrand, but it has 9/4 as a coefficient. So, this is, well, to save some room, this is equal to I. Aha! So it's kind of like a recursion, right? So like it just kind of I wouldn't say exactly repeat itself, but in a way it kind of did. So this is 9/4 of I. This is I here. This I is here. We can actually put this to the other side. So 9/4, you get I plus 9/4 of I, right? What's 1 plus 9/4? That is 13/4, right? So we get 13/4 of I equal to e to the 2x over 2 sine of 3x minus 3/4 e to the 2x cosine of 3x. And then this is almost your answer, except that we want I, not 13/4 of I. So how do we find I? We just we divide this to the other side, meaning that we multiply the reciprocal. So I, and then times all this by 4/13. We get 213 e 2x sine 3x minus for 313 e to the 2x cosine of 3x plus c. And this is our answer, right? So this recursion, letting an integral equal I, and then notice that this is I, noticing that this is I, the same thing like this. This is uncomfortable to a lot of students. So it's very, very tricky. This is the hardest part about learning integration by parts in your Calc 2 class. So let's practice some more, right? We have another very common one, secant cube dx. What do? First instinct is secant x and secant square, right? Derive this, we get, well, I'll put a negative there for now, but deriving this is secant x tan x, and then integrate this, we get tangent x. Okay, that negative comes from alternating. Now we have secant x tangent x minus secant x tangent square. What do we do now? Well, we can integrate again, or not integrate again. We can kind of use a trig identity, right? This becomes secant square of x minus 1, right? So now this is secant cube of x minus secant of x dx. So now we have secant of x tangent of x minus the integral of secant cube plus, and then the integral of secant x is ln of secant of x plus tangent of x. Awesome, but what now? Well, remember that this is I, and this equal to this thing, and I is here. Wait a minute, isn't this and this the same thing? Yes, it is. So what we have here actually is this is equal to I. So this is equal to I. And we can combine this to the other side. You get 2I equal to secant x tangent x plus ln of secant x plus tangent of x. Our I is just everything, literally everything divided by 2. So our integral is a half of secant x tangent x plus a half of ln of secant x plus tangent x plus c. And you're done. All right, so very tricky. In fact, this integral is evil. It's a nightmare to a lot of Calc 2 students. But yeah, recursions. So very tricky. All right, last one. You think you can do it? Try doing it by yourself. If not, well, here I go. So, if you're very advanced, you can use complex analysis or complex algebra with this, but I'm going to stick with integration by parts. So, let's go ahead, derive sine ln of x and integrate 1 over x4. So I get I equals to negative this sine of ln of x, and then we get plus to what? Cosine of ln of x of 3x to the power of 4 dx. We can do this again, right? cosine of ln of x. You get 1 over x over 4. We did this already, so we'll just do it again. And so now we get, just rewrite this, plus this is now minus cosine ln of x. Don't forget this 3, okay? Do not forget that 3. If you need to, you can put it here so that you don't forget that 3. Okay, so this is now like what, 9x cubed, and then here this is like 1/9 of sine ln of x over x4. Oh, would you look at that? Oh my god, it's the same integrand. Oh my god. So this is now I, 1/9 of I. And this is I, this is I. We can take this to the other side. We get what? 10/9. We get what? Negative 3/10. Wait, yeah. 9 over 10. Yeah, negative 3/10. Sounds right. And then 9 over, yeah. That sounds right. Don't forget absolute values. This would have killed me. And I believe this is the answer. All right. Awesome. So, very tricky. Again, this is just very uncomfortable to a lot of beginners, but it is something that you must get used to in speed integration. Okay? Awesome. Oh boy. Now we're on to level 3. This is where things gets very, very uncomfortable, but you must get used to it. We gotta learn how to deal with very uncomfortable integral problems. Okay? So here, this is uncomfortable, right? Looking at this, it's like, do I u sub this? But then you make this into a bigger polynomial and it's just nasty. You don't want to deal with that, right? What we can do is we can do integration by parts. Let x plus 1 cube be derived, and then we have x minus 1 fourth. So now if we continue this chain, oh my god, okay. So now this, or let me probably color code that. This, okay, this, and this. Just don't lose track. I didn't realize I needed more room, so I probably should have spaced this a lot more out. But anyways, it turned out nicely, so we just have a very, very long answer. So let's do this first because it's positive. We get a half of ln of x minus 1, and then minus a half of x minus 1 at the bottom, x plus 1 at the top. And then a half x minus 1 square here, half x plus 1 square here, and then minus, oh, this is 1/3. Okay, well, I trust it. I'm just gonna write like this. There we go. And then plus c. Alright, so a very awkward case where we use integration by parts on a rational function. In some cases, sometimes we gotta grow some balls. So even though this looks nasty, we're still gonna perform integration by parts. I know, it's okay. It's gonna be okay. It's gonna be okay. We're gonna derive this and hope that it's gonna be okay. Let's see. If we do this correctly, what is the derivative of this? Well, this is, we can rewrite this as what? X, this is equal to x plus 1 minus 1. Okay, so derive this, and we get something like positive 2 over x plus 1 square. and this is x. Okay, so we get x inverse tangent of x minus 1 over x plus 1, then minus the integral of, well, we can cancel this out here. Just don't forget to do this part. So we get like 2x x plus 1 square plus x minus 1 square. Right. And this part here can be simplified to what? What is this? X squared, 2x squared, plus 2x minus 2x, so that's going to cancel out. Plus 1, plus 1. Hey, look at this. The 2 cancels out. So we actually, this is just this. Literally. How awesome. So, x inverse tangent of x minus 1 over x plus 1. And this is just, be careful, it's minus. Okay. Half of ln x squared plus 1. And we are Gucci. So, right, again, this scares us, and doing this scares us, but then at the end, it gives us a very, very clean answer. Okay? All right, just like before, again, a very uncomfortable integral to do integration by parts. All we gotta do is just grow some balls. Just gotta grow some balls here. All right. Balls, ovaries, anything that that keeps you confident, I guess. So here we integrate, derive. This is x plus 1 over x plus 1, 1 minus 1 over x squared. Don't forget minus here. And then this is x cubed plus x squared plus x. Oh, would you look at this? Watch this. Well, first of all, this, right, x cubed plus x squared plus x, then ln x plus 1 over x plus 1, and then minus, and then here, we can multiply x squared top and bottom. This is going to be x squared minus 1. This is going to be x cubed plus x squared plus x. Then this and this is going to cancel each other out. How beautiful. So this is, we literally have our answer now. It's just this very long term, 1 over x plus 1, and then minus x cubed over 3 plus x, and plus c. And we are Gucci. That's it. We're done. That's all it takes. We just got to grow some balls. Try integration by parts. Again, this whole idea of this level is we're dealing with integrals that makes us uncomfortable. But at the end, it cancels out very nicely. Integration bees do this a lot of times. So try experimenting with integration by parts. Okay? Alrighty, on to level 4. Oh boy. Now you're in some speed integration territory, right? So now this is, again, at this level, I'm going to assume that you're very, very comfortable with integration by parts. And I'm talking about like, this is going to be like intermediate level speed integration. So this level is where you have to kind of integrate in the integral. Here's what I mean by that. Like sometimes when you do integration by parts, you have to end up integrating this function, and to know the integral of this, you literally have to do some sort of mini integration by parts. That type of thing, if you know what I mean, right? So for this example, right, we're told to use what? Some rule Eliate, right? And we always do logarithm first. Oh, well, guess what? They're both logarithms. What now? Right? What do we do here? We derive ln of 1 minus ln of x here. And then we integrate ln of x here. Deriving is easy, right? Because it's just this. And then it'll just be whatever, negative 1 over x right? The negative cancels out from the alternating thingy. And then now, when you integrate this, you have to kind of scooch over to the other side, integrate ln of x, do your whatever, integration by parts, blah, blah, blah. You should end up getting x ln of x minus x, right? Oh, but look at this. Okay, so our answer is x ln of x minus x ln of x1 minus ln of x. Okay, and then this is plus. Oh, would you look at that? This is x ln of x minus 1, but what we have here is x1 minus ln of x. This cancels out, and this cancels out. We just get a negative 1. So our answer is literally, well, if you were actually computing and you got this integral, instead of rewriting this whole thing, you grab an eraser, erase this part, and then put minus x plus c, rather than rewriting everything. And that is how you obliterate your opponent. Okay? All right. We're only going to use 2 integrals for level 4. So this is going to be the last integral for level 4. And then we're going to move on to level 5. Again, same concept, right? We're going to deal with very uncomfortable integrals. And obviously, we're going to derive this, but then you have to integrate this part. And this, you have to scooch over and do like a mini integration by parts here. So, let's go ahead. Secant x plus tangent of x. And this is equal to secant of x. When you derive it, you get secant of x, but we'll put a minus here. And then here, what I like to do, actually, let's multiply 2 and then divide by 2. We get 2 cosine squared minus 1. This is cosine of 2x. So, cosine of 2x over 2. This is going to give me what? 1/4 of sine of 2x. Okay. Well, there you go. So you don't actually have to integrate cosine square or anything scary. You could just use trig identities. Okay? So, all right. Well, this is literally it. 1/4 sine 2x ln of secant of x plus tangent of x. And then minus 1/4 of, well, this is 2sc times secant x. This is going to cancel out. So we get 1/2 of sine of x. And this is going to give us, right, you can literally like erase everything here and get something like plus what? This ended up giving us 2 sine of x, right? Well, negative. And so integrating this would give us 2 cosine of x. Wait, yes. I was like, wait a minute, shouldn't it be 2x? I hesitated a little bit, but this should be our answer. You have finally reached level 5. This level of integration by parts, again, I'm not going to mention semi-integration by parts or whatever other techniques, just plainly integration by parts itself. And oh my goodness, level 5, this is where we get really uncomfortable. We deal with very uncomfortable integrals to the point where it feels bashy. Okay? And this is a very famous integral that will test how much balls you have for integrating by parts. Okay? This integral is what I use to test how fast you can do integration by parts. So, but with these bounds, it's a little uglier because now it's improper, right? And I do this so many times to train myself in integration bees that I just end up memorizing this answer. So, hopefully I should get to that. But let me show you how to actually do this. So in a speed integration standpoint, what I would always do here is I would always derive this and integrate this. Okay? The reason why I like this better than this is because, well, if I get here, let's say, right? And then this. Then I have to deal with this term, and then I have to deal with, okay, well, this is just u substitution, but then I have to deal with this term here. And then you have to do another, another integral with this, and then do another integration by parts that I'm not comfortable. Well, it's not just that, right? ln this, you get 1 over x, and then you're going to get something like this, and then you have to do like trig sub. And it's a lot of steps. So my secret is do this path. And the reason why I like this better is because here I can go like, okay, well, this is what? X inverse sine of x minus root of 1 minus x squared. I think it's minus. Let me double check that. Oh, it's positive. I think it is positive. Okay. So now here, I like this because then, I have my answer here. ln of x. And then this thing. This long whatever. Okay. And then I have what? I'm back to minus what? Inverse sine x. And then plus this. Oh, well, look, that's amazing. This is so much better than the other one. Why? Because we literally just, we did this. We literally just did this. Isn't that amazing? That's literally, the answer to this is literally this. Right? So what do you do to obliterate your opponents? Is you grab your erase board, erase this, right? Obviously, you cannot do this on a whiteboard, right? But what you can do is you can, grab your erase, your dry eraser, erase this, right? And then put parentheses. Oops, here. I'll actually demonstrate it. And do ln of x. Well, it was a minus integral, right? It was a minus integral. So what you would do is do ln of x minus 1. And then you do this part. Well, again, this is a minus. Be very careful. Okay? So now, awesome. Okay, so you don't have to rewrite everything. Okay, this is speed integration. We want to obliterate our opponent. So now here, this is from 0 to 1. This is 0 to 1. Okay, this is integration by parts. Sorry, this is trig substitution. So, I mean, you could do u sub if you want to, if you're really comfortable with that. Or if you love trigonometry, let x equal sine theta. Right? So now this is like, what? Pi over 2. What? This is cosine square over sine. We get 1 minus sine square over s. And now this is like cosecant theta. This is how I actually compete. Like I would have like my left hand would be like the eraser, and I would just, instead of rewriting everything, I just constantly erase, right, erase, exactly like this. And then here I would focus here. Oh, well, ln of 1, that's 0, minus 1. That's 0. This is, okay. So I get like -1 of, what, pi over 2 minus ln of 0. Oh no. Oh no. Right? This is no bueno. So I actually have to write a limit of x to 0. This part always traumatizes me. This part always traumatizes me because it's so tedious. It's so scary because you genuinely have to be very, very careful with this. Okay. This gets me all the time. I can never mathematically properly compute this because this is horrible. You can't compute this by itself. If you compute this, it diverges. So you actually need this part to be computed. So here we get what? This is positive sine theta. So I'll actually implement this so that I don't get confused. This is negative cosine theta. negative cosecant theta is positive ln of cosecant theta plus cotangent theta, right? From pi over 2 to 0. Oh my god. Woo! Thank God I have this integral memorized, because this would be a pain to do. So plugging in 0, still divergent, so you gotta be careful. You gotta wait. You gotta plug in this. Pi over 2, that's 0. Plug in pi over 2.
Oh my god, what I do wrong?
Y'all didn't see anything. I don't know what you're talking about. This is all in one run. I don't know what you guys are talking about. I didn't make any mistakes. I am just as accurate as, here. Let's just continue. So plugging in 0 here, this is ln of 2, or minus ln of 2, because cosine of 0 is 1, 1 plus 1, 2. So we get minus pi over 2 plus 1 minus ln of 2. So we don't have to deal with this. And now, here, this, all right. So let me just scoot this. So now this is by itself. And so now, plug in 0, we get cosine of 0, which is 1. This one's 0, so we get 1 here. And that's where we get 2 minus pi over 2 minus ln of 2. Awesome. And this is literally our answer. But how do we show that this is equal to 0? I got you. Factor ln sine theta minus, I'm sorry, not minus. We're factoring them. So this is 1 minus sine theta minus cosine theta. Okay, be very careful. It's not plus, right? We're distributing the negative. So now how do we do this? Divide sine theta square, multiply theta square here. And what this does is this gives me a baby limit. Okay, this has to be, you can only do this when the baby limit is equal to a non-zero limit, right? So this is safe for me to do because I know this is like 1 minus cosine theta. And this is like what? Minus 1. This is equal to negative 1/2. Okay. As long as it's not 0, then I'm safe. Okay. I can do this. As long as it does not equal to 0. It has to be a non-zero limit. So this is equal to negative theta over 2 ln sine theta. Now I feel more comfortable doing L'Hopital's rule. This is negative 1/2 of the limit of theta. And then on top, we get cotangent theta. On the bottom, theta square becomes 1 over theta square, 2 over theta cube. The negative cancels out. And then we get theta cube. This is now 4 at the bottom, but it doesn't really matter because theta cube times cosine theta over sine theta. I mean, we get theta, this converges to 1. Theta square of cosine theta, this converges to 0. So the limit is equal to 0. Therefore, our answer is just this. Oh my god. What an awful improper integral. This is the worst improper integral to deal with. Well, actually, I lied. I've dealt with worse. But I won't talk about that. Yeah. Okay. Next level 5 integration by parts integral. Oh my god. Can this get any worse? Well, actually, no. I lied. Actually, I'm gonna cheat a little bit. For those who don't know, this is equal to inverse cosh. This is why you should never let me be an I mean, I would love to be an integration B problem writer for you. But just I promise not like this. Oh my god. That was all just a dream. That was all just a dream. I don't know what you guys are talking about. Whatever you just witnessed, that was all a dream. I don't know what you guys are talking about. Actually, oh no, you didn't see anything. Okay. So, inverse secant plus inverse cosh. Awesome. So now we have inverse cosh all multiplied by this. Cosh inverse. And then now it's just, this is just half of inverse cosh square. And then minus Boy, disgusting. Okay, so here, this is this. This is this. Oh, so much nicer. Oh, thank God. Okay, so this is now inverse secant of x squared minus 1, and then plus, well, these two are going to cancel out, so we get ln of x. Yeah, boy. Woo! We are not putting in bounds. I swear to God, we are not putting in bounds. Please don't do that. Well, actually, no, it wouldn't be as bad because x, you can't have a bound 0. That would make it diverge. So we are Gucci. Okay, awesome. Okay, that was our last integral. So I hope that was entertaining and a bit helpful. And yeah, those are the 5 levels of integration by parts. Thank you so much for watching, and I'll see you guys in the next video. I have been tormented enough. See you guys.